Six Sigma is one of the most powerful tools in all of process improvement. But from my experience, most executives either don't understand it, they don't utilize it, or they overcomplicate it. Rather than taking a bunch of courses that make it overly complex, let me explain to you how the power of this tool can improve your processes in this short tutorial. I'm Ron Eggert. This is the Propellant Pulse. Let's talk Six Sigma. Okay, Six Sigma is two things and two things only. It is reducing variation and moving the mean of your process. That's it. And it must be done in that specific order. And this is where I see executives get tripped up. Everybody wants better results. They want to move the mean. They want to do it right now. Let me give you just a quick example of how this works so you can understand and put this into practice with your business today. And I'm going to use an example from my time in the U.S. Army that might be a little bit relatable to some of you all out there. In the U.S. Army, when soldiers qualify on their individual rifle, we use the Six Sigma process to the letter. And I'll explain how. First, you have to understand that every soldier is different. They shoot differently. Every rifle system is different. They all wear differently. They all have small variations in how they're designed. And before a soldier goes to qualify on their rifle, we take them through a process, a range called a zeroing range or a zero process. If you look at the lower left-hand quadrant, you're going to see the first step in zeroing your weapon. And this is what we hope to get to and we need to get to in the zeroing process. The soldier is able to replicate the same shot over and over. It's a nice tight shot group. There's little variation in it. And we don't so much care about it hitting center mass of the target yet. We just want to make sure that that soldier is hitting the same place every time, which means there's little variation in the weapon system. There's little variation in the soldier. Thumbs up. Now I want you to look at the top right-hand quadrant. This is a soldier that's sort of all over the place. Now, if you look at the main mass shot group, you're going to see it's not tight. The mean might be on point, but there's a lot of what we call common cause variation in there. So the soldier's doing things fundamentally different every time they're shooting, or there may be some problem with the weapon system. It's usually not that. And if you look just even more to your right, where you see that one-off shot, that's what we call special cause variation. That should be easily identified. Either a rough trigger pull or something externally happened with the soldier during that shot. But ultimately, even though in this quadrant the mean might be on point, we're not looking for this. We're looking for that consistent shot group no matter where it is on the target. If you look at the bottom right-hand quadrant, this is probably the worst place to be. Not only is the soldier not even close to center mass of the target, but most importantly, their shot group isn't tight, which means that there's variation within the soldier from a common cause perspective, and we also need to engineer that weapon to get them to that center mass. Now let's go back to the left-hand quadrant. So once we verify the soldier has a nice tight shot group, low variation, doing the right thing, all we do is simply calibrate the weapon system. We adjust the front sight post and the rear sight post to dial them in to center mass. That's how easy it is. Once we get to this point, no matter where they're shooting on the target, it's very simple to dial them in and get them a nice, accurate shot with low variation that's going to hit center mass on a consistent basis. The theme here is to first focus on variation. Stop fixating on the mean, on the performance. You're never going to get there if you don't reduce the variation in your process. Validate that your operators are doing the same thing every time. Your machines are functioning the same way every time. Your process is getting the same output every time. Once you do that, it's simple engineering to get the outcome that you want and to hit the mean that you want. That's how simple it is to use Six Sigma. That's your Six Sigma lesson for today. Once again, I'm Ron Eggert. This is the Propellant Pulse. Until next time.